For the last few years, the AI world has been defined by an arms race of scale. Companies like OpenAI, Google, and Meta have been locked in a battle to build the biggest, most powerful models imaginable. We're talking models with hundreds of billions, even trillions of parameters, trained on nearly the entire internet, costing hundreds of millions of dollars to develop. The philosophy was simple: bigger is better. More data, more computing power, and more complexity would inevitably lead to more intelligence. But then, a quiet disruption began to ripple through the industry, coming from an unexpected corner of the world. A Singapore-based startup named Sapium, founded by a team of brilliant minds, some of whom honed their skills at legendary labs like DeepMind and Shy, decided to ask a different question. Instead of asking, how can we make our models bigger? They asked, how can we make them smarter? They looked not to more silicon, but to the most efficient and powerful problem-solving machine ever created, the human brain. The result of their inquiry is HRM, a groundbreaking AI agent that has sent shockwaves through the research community. On the surface, it's unassuming. It's a compact model, a flyweight in a world of super heavy weights. But when put to the test on tasks that require genuine reasoning and problem solving, this little A isn't just competing. It's outperforming its colossal rivals. This isn't just an incremental improvement. It's a signal of a potential paradigm shift, a leap in AI's ability to move beyond pattern recognition and into the realm of true flexible reasoning. To understand why HRM is such a big deal, you first have to understand how most of today's famous AI models, like ChatGPT, actually think. They predominantly use a technique called chain-of-thought reasoning. Imagine it like a line of dominoes. You give the AI a problem, and it calculates the first step, then the second, then the third, in a linear, one-way sequence. It writes out its thinking process, step by step, hoping that each domino correctly knocks over the next. This works incredibly well for many things, but it has a critical, fundamental weakness. What happens if one of those dominoes is slightly out of place? What if the AI makes a single logical error early in the process? The entire chain collapses. The final answer will be wrong, and the AI has no inherent ability to go back, recognize its mistake, and correct its course. It's like following a recipe and realizing you added salt instead of sugar in the first step. You can't fix it by just continuing to the end. The whole batch is ruined. HRM throws this entire concept out the window. It doesn't think in a straight line. It thinks in a loop. Instead of a line of dominoes, picture a sculptor working on a piece of clay. They shape a bit, step back, observe their work, decide what needs to be changed, and then lean in to make an adjustment. They repeat this process over and over, constantly refining their creation based on feedback. This is precisely how HRM operates. It mimics the human brain's iterative process of trial, error, and correction. It can tackle a problem, assess its own progress, identify flaws in its strategy, and then loop back to try a different approach. This ability to self-correct and dynamically adjust its thinking process is what sets it so profoundly apart from traditional AI. Now, you might be thinking, okay, so it's just a smaller version of GPT-4, right? Absolutely not. And this is a crucial distinction. Many companies have tried to create light versions of large language models by simply scaling them down. But that's like trying to make a sports car by just shrinking a semi-truck. You end up with something that's not particularly good at being either. HRM is a distinct creation from the ground up. It's not a transformer, the dominant architecture behind models like ChatGPT. Its design philosophy is completely different, borrowing principles directly from the layered, hierarchical way our own brains process information and make decisions. Think about it. When you decide to cook dinner, you don't process every single atomic action at once. Your high-level brain says, let's make pasta. Then lower-level processes kick in to handle the subtasks. Get the pot, boil the water, find the sauce. These layers work in concert. The most staggering part is the efficiency of this design. HRM boasts a mere 27 million parameters. To put that in perspective, GPT-1, the model that kicked off this whole revolution back in 2018, had 117 million parameters. Today's giants have parameters in the hundreds of billions. Yet, this tiny 27 million parameter model is running circles around modern heavyweights, like Claude 3.7 and OpenAI's O3 Mini on complex reasoning benchmarks. It's a testament to the idea that the quality and structure of the connections matter far more than the sheer quantity. It's not about having a bigger brain. It's about having a better organized one. So, how does this brain-inspired architecture actually work in practice? HRM operates on an elegant and powerful dual-structure system. You can think of it as having two core components working in a perpetual, dynamic partnership, a high-level planner and a low-level worker. The planner is like the CEO or the project manager of the operation. It looks at the big picture. When presented with a complex problem, like solving a maze, its job isn't to figure out every single turn. Its job is to strategize. It might say, our goal is the exit. A good general strategy would be to head north and prioritize right-hand turns until we hit a dead end. It sets the overarching plan. Then it hands that plan down to the worker. The worker is the diligent, fast-acting engineer on the ground. It takes the CEO's strategy and executes it, step by step, moving through the maze swiftly and efficiently. But here's where the magic happens. The worker isn't just a blind follower. It constantly sends feedback up to the planner. It might report back, executing the prioritized right turn strategy led us into a closed loop. We've been here before. Upon receiving this feedback, the planner does something most AI models can't. It reevaluates. It recognizes the initial strategy was flawed and devises a new one. Okay, the planner might say, Plan A failed. Let's scrap that. Plan B, backtrack to the last major intersection and explore the Western Passage this time. This interaction creates a tight, iterative loop of planning, executing, and refining. It's a conversation between strategy and action. This allows HRM to adapt on the fly, to learn from its mistakes within a single problem, and to navigate complexities that will completely derail a linear, chain-of-thought model. It's reasoning with agility. Talk is cheap, especially in the world of AI. So, let's look at the cold, hard numbers, because this is where HRM's unique approach truly shines. The researchers tested it on some of the most notoriously difficult reasoning benchmarks out there. One of the gold standards is the Archeggie benchmark, a collection of abstract visual reasoning puzzles that are incredibly easy for humans but fiendishly difficult for AI. It requires an intuitive grasp of patterns, objects, and transformations. On this test, HRM scored an impressive 40.3%. For comparison, Claude 3.7, one of the most advanced models from Anthropic, scored just 21.2%. OpenAI's powerful new O3 Mini managed 34.5%. HRM didn't just edge them out, it significantly surpassed them. But the most jaw-dropping results came from two other tests, Sudoku and mazes. They presented the A's with hard and extreme Sudoku puzzles, the kind that can stump even seasoned human players. HRM successfully solved 55% of them. Then, they moved to massive 30 by 30 mazes, complex enough to have countless dead ends and looping paths. HRM found the optimal, shortest path in a staggering 74.5% of the tests. And what about its larger, more powerful competitors from the big tech labs? On both the extreme Sudoku and the 30 by 30 maze tests, they scored a flat 0. Nothing. They couldn't even get started. This wasn't a failure of knowledge. It was a failure of reasoning. The step-by-step approach of the larger models simply couldn't handle the long-term planning, backtracking, and strategic thinking required. They'd make a few moves, get stuck in a logical corner, and have no mechanism to escape. HRM with its planner worker loop, could navigate these challenges with an almost human-like flexibility. Perhaps the most economically and environmentally significant aspect of HRM is its incredible training efficiency. The dominant narrative in AI has been that models need to be pre-trained on gargantuan datasets. We're talking petabytes of text and images, requiring months of time on thousands of high-powered GPUs, consuming the energy of a small city. HRM turns this idea on its head. To achieve its remarkable benchmark scores, it required minimal, highly focused training, just 1,000 examples for each specific task. Think about that. Not a billion web pages, but a curated set of 1,000 puzzles. To reach a professional level of performance on Sudoku, a task that has stymied other models, HRM needed only 2 hours of training on a single GPU. This is a paradigm shift in efficiency. It means that developing highly capable, specialized AI no longer has to be the exclusive domain of trillion-dollar corporations with endless resources. It democratizes the development of reasoning AI. A small university lab, a startup, or even a dedicated hobbyist could potentially train a powerful reasoning model without breaking the bank or melting the polar ice caps. It proves that intelligence doesn't have to come from brute force data consumption. It can come from elegant, efficient design. So, why are the massive transformer models so rigid? Their architecture is built around a fixed number of processing steps or layers. When you give a transformer a problem, the data flows through these layers one by one, and what comes out at the end is the answer. It can't decide to run the data through a few extra layers if the problem is particularly tricky. The computational budget is fixed. HRM's architecture, especially a variant that uses reinforcement learning, shatters this limitation. This version of HRM can autonomously decide how many thinking loops it needs to solve a given problem. For a simple task, the planner and worker might interact just a few times and arrive at a solution quickly. For a highly complex problem, like that 30 by 30 maze, it can decide to run the loop hundreds or even thousands of times, iteratively refining its path until it finds the optimal solution. This is a profound step closer to how humans think. We don't allocate the same amount of mental energy to tying our shoes as we do to solving a complex physics problem. We adapt our cognitive effort to the difficulty of the task. HRM is the first AI model that can do the same, giving it a level of flexibility and adaptive intelligence that its predecessors could only dream of. The technical innovations of HRM go even deeper, right down to the way it learns. Most modern AI models are trained using a process called backpropagation. To simplify a very complex idea, it's a method where after making a mistake, the error signal is sent all the way back through the entire network, requiring a huge amount of memory to keep track of every calculation. It's effective, but it's also computationally expensive and biologically implausible. Our brains don't work that way. HRM uses a more efficient method with localized gradient updates. Instead of a global review process, corrections are made in smaller, localized parts of the network. This is not only faster and requires far less memory, but it's also much closer to how neuroscientists believe synaptic connections in the brain strengthen or weaken. The real-world consequence of this efficiency is incredible: scalability. Because HRM is so lightweight and memory efficient, it doesn't need to live in a data center. It can run on modest hardware. We're talking about a standard laptop, a high-end smartphone, or an embedded chip in a robot. This unlocks a future where powerful, reasoning AI isn't something you access through the cloud. It's something that runs locally on your devices. Imagine a robot that can navigate a cluttered, unfamiliar environment without a constant connection to the internet, or a medical device that can perform complex diagnostics right in a rural clinic. HRM's design makes this future tangible. This isn't just a fascinating research project. The startup Sapien is already deploying HRM to solve critical real-world problems. They're not just chasing benchmark scores. They're chasing real-world impact. In healthcare, they are using HRM to help diagnose rare diseases. This is a perfect application for its reasoning abilities. Diagnosing a rare illness is often a process of elimination, of forming and testing hypotheses based on disparate symptoms and lab results, a task that requires exactly the kind of iterative, corrective thinking that HRM excels at. Another groundbreaking application is in seasonal climate forecasting. They are using HRM to predict climate patterns with a reported 97% accuracy, a task of immense complexity with variables that can overwhelm traditional models. By finding the deep, logical connections within chaotic climate data, HRM is providing insights that could be vital for agriculture, disaster preparedness, and resource management. The fact that the team is composed of ex-engineers from places like DeepMind and XAI lends immense credibility to their work. These are people who have been at the forefront of the bigger is better movement, and they've chosen to pioneer a different path, one inspired by the elegance and efficiency of biology. In a move that stands in stark contrast to the increasingly secretive nature of the big AI labs, Sapien has made HRM open source. Its code is available on GitHub for anyone in the world to download, inspect, build upon, and improve. This is an invitation for global collaboration. They believe that the future of AI shouldn't be built behind closed doors, but out in the open by a community of passionate developers and researchers. It's important to note that HRM in its current form is not a conversational chatbot. You can't ask it to write you a poem or summarize an email. Its expertise is narrow but deep, pure, unadulterated reasoning. It signals a critical shift in the AI landscape, a move away from building all-in-one models that can do everything passively, and toward creating specialized tools that can think exceptionally. This could be the beginning of a new branch on the evolutionary tree of AI, paving the way for accessible, truly intelligent systems to become a part of our everyday devices. HRM doesn't exist in a vacuum. It's part of a growing wave of experimental architectures that are challenging the dominance of the transformer. We're seeing other exciting projects like Sakana AI's continuous thought machines and Google's diffusion-based models, all of which are fundamentally rethinking the design of artificial minds. It feels like the Cambrian explosion of AI, a period of rapid and wild diversification. The story of HRM is a powerful reminder that in the race to build artificial general intelligence, the biggest breakthroughs might not come from the biggest players. They might come from a small team with a brilliant idea, inspired by the 3 billion-year-old R&D project we call life. Its ability to outperform models thousands of times, its size using a fraction of the data and energy, isn't just a technical achievement. It's a philosophical statement. It suggests a future where AI is not defined by brute force, but by elegance, efficiency, and a genuine spark of something that looks an awful lot like reason. As we step back and look at this incredible story, what can we take away from it and apply to our own lives? I think there are a few profound lessons here. First is the power of efficiency over brute force. In our careers and personal projects, we often think we need more resources, more time, more money, a bigger team. But HRM teaches us that a cleverer, more elegant approach can often outperform a massive, resource-intensive one. It's a powerful argument for working smarter, not just harder. Second, it highlights the wisdom of looking to nature for inspiration. The human brain is the product of millions of years of evolution. By mimicking its principles of iterative layered thinking, the creators of HRM unlocked a new level of performance. It's a lesson to all of us to sometimes look for solutions not in the newest, shiniest technology, but in the time-tested systems that exist all around us. And finally, the most human lesson of all is the importance of the iterative loop. HRM's strength is its ability to try, fail, assess, and try again. This is the very essence of learning, creativity, and resilience. We shouldn't fear making mistakes. We should build systems, both for our technology and for ourselves, that allow us to learn from them and adapt. The path to success is rarely a straight line. It's a loop of continuous improvement. So I leave you with a few questions to ponder. Where do you think a compact, powerful reasoning, AI could make the biggest difference in your daily life? Do you believe this new wave of brain-inspired models is the true path forward? Or will the sheer scale of the giant models ultimately win out? I'd love to hear your thoughts in the comments below. And if you found this exploration into the future of AI as fascinating as I did, please do me a favor and hit that subscribe button and ring the bell so you won't miss our next deep dive. It really helps the channel and it ensures you stay in the loop on the technologies that are changing our world. Until next time.